Question says, when the sun is directly overhead, the surface of Earth receives that much energy per meter square. It means it's clear that is the intensity. So assume that the light is monochromatic with average wavelength. They have given wavelength also 500 nanometer. That no light is absorbed between the sun and the earth surface. The distance between the sun and the earth is given to be 1.5 10 to the power 11 meter. Calculate the number of photons falling per second on each square meter of earth surface directly below the sun. You see, so you take here one, that will find a part. Let's say that is the earth and that is the sun. Okay, and light is falling directly here, and we'll take this area 1 meter square of the earth. How many photons are falling on that particular area? So you see, that is the intensity of light, dn upon dt, that is the number of photons falling per unit time. Hc by lambda, that is the energy of photon, and per unit area. So you find 1.4 10 to the power 3, that is given to be the intensity. Dn upon dt, number of photons per unit time and per unit area we have to find, and that is hc by lambda here, hc by lambda. So you will transfer this, okay, to this side. So we'll find 1.4 10 to the power 3, that is 500 10 to the power minus 9, that is the lambda value. You put here h value is 6.64 10 to the power minus 34, and c value is 3 into 10 to the power 8. Now we have to calculate what dn upon dt, and that area, number of photons per unit time per unit area, we have to find. So we have to calculate this value. So you see, if you multiply this with this, approximately 20 you will find, and this is 1.4, and you will take 5, so it will be 10 to the power minus that 2, and 10 to the power 5, so you will find 10 to the power minus 4 almost, and here will be 20, and that is you solve 20 30 minus 34 and plus 8, so you will find 20, that is 10 to the power minus 26, and that is dn upon dt, and here is the area. Now you see, if you calculate this, you'll find this is what 7, and 7 by 20, and here it will go in numerator, so it will be 20 10 to the power 22. So okay, so that is dn upon dt. So here you say you can take this 70 20, so it remaining will be 10 to the power 21, that is dn upon dt, and that is n. So you see, this is cancelled, so you will find 3.5 10 to the power 21. So these are the number of photons falling per unit time per unit area of the earth. Okay, now we'll go to the second question. What the second question is saying, how many photons are there in each cubic meter near the earth's surface at any instant? Means at any instant how many photons are living in a cubic meter, means in a volume, in this volume, in each cubic meter how many photons are living. So you see, you can do one thing. Basically you find this number of photons per unit time per unit area. So its unit will be number of photons per unit time per unit area. If you divide this by what? Velocity, that is the speed of photon. Speed of photon is what? Speed of light. They will find the number of photons per unit time per unit volume in unit volume. So you see how we have to do, that is dn da dt. You see, if you divide with speed of light, this speed of light, so its unit of speed of light is meter per second. So you see, here will be go second, here meter, and here you'll find 3.5 10 to the power 21, and that is 3 into 10 to the power 8, that is the speed of light. So you see, the unit is now, this is volume, area into meter, means that basically depth we have taken, that is the speed that is the depth covered by the photons in unit second. So it will make what volume. So and this second will cancel. So you will find number of photons per unit volume, that is meter cube. So you will find this is 3.5 and this 8. So you will find it will subtracted. It will be 13 divided by 3. If you divide this, you will find 1. This is approximately, you can write 2, that is 10 to power 13. So that many photons will be available at any instant in unit volume of the earth surface. Now, so that was the second part. Now we are coming to the third part. How many photons does the sun emit per second? How many photons are emitted by the sun? So you see, number of photons emitted by sun per unit area. If we multiply the area in which the photons are distributed, so we'll find the number of photons distributed by the sun. So what is the area? You see, if this is the distance between sun and earth, so that is the 3D structure. Is here the complete sphere will be formed like this, like this. Okay. So its distance will be what that is given in the question. Here you see 1.5 10 to power 11, and that is spherical area will be what 4 pi r square. So just here we have to multiply the number of photons per unit time per unit area and into this 4 pi spherical area. So you'll find what number of photons emitted by sun. So you see, you come here, so you'll find dn upon dt. We have calculated here that the value is 3.5 10 to power 11 21. So we will put here 3.5 10 to power 21. We have calculated this, and just will multiply what area 4 pi and 1.5 10 to power 11 whole square. So you see how to calculate this. That is very important. How the calculation is done. 21 4 pi. That is 1.5 means 15 square. So you can write 2.25, and that is 10 to power 11. So whole square 10 to power 22. So you see, now you multiply this and this. This is 3.7 multiplied by 4. So you will find 14 in this with 3.14 and 2.25. So almost it comes out to be 99 into 10 to power, and that is 43. So if you arranges, you will find 10 to power 4 photons. So that many photons are emitted by the sun. Thank you, everyone.